combination of figures. And also we discussed how to find the length and area of the racing track. This section also we are continuing with the areas of combination of plane figures. Today we will discuss about some questions from the exercise 12.3. Let us see some questions. In the figure, OACB is a quadrant of a circle with radius 3.5 centimeter. And if OD is equal to 2 centimeter, find the area of the quadrant OACB and shaded region. You can see the shaded region in the figure, and it's given for you. OACB is a quadrant of a circle. First you want to find the area of the quadrant, then we want to find the area of the shaded region. Two questions are there. To find the area of the quadrant of a circle, we know that its quadrant is a sector of a circle. So the angle of the sector or angle of this quadrant is equal to 90 degree. And the radius of this quadrant is given for you, that is 3.5 centimeter. So if you know the center angle and the radius, we can find the area of the quadrant. So first question answer, area of the quadrant is equal to theta by 360 into pi r square. Here theta is equal to 90 degree because it's a quadrant of a circle. So 90 by 360 into pi r square, that is equal to 90 by 360, that is 1 by 4 pi r square. Directly we can use this 1 by 4 pi r square, that is 1/4 of the area of the whole circle, that is the area of the quadrant. So 1 by 4 pi r square, now we can substitute the values. 1 by 4 into 22 by 7 into radius is equal to 3.5. So 3.5 whole square, that is equal to 1 by 4 into 22 by 7 into 3.5. We can change the decimal, you can change to fraction form, then your calculation will be little more easy. If you change 3.5 as a fraction form, it will be 35 by 10. 35 by 10, the lowest form is 5 is the common factor, 7 by 2 is the lowest form. So 3.5 we can write it in the fraction form, then it will be 7 by 2. So 3.5 we can write 35 by 10 into 35 by 10. Instead of writing this, you can write the lowest form. 7 by 2 into 7 by 2. 7 and 7 will be cancelled, and in 22, 1 2 is 2, 11 2s are 22. That is equal to 11 into 7, 77 by 4 2s are 8, 77 by 8 centimeter square. That is the area of the quadrant OACB. Next we want to find the area of the shaded region. To get the area of the shaded region, we want to subtract the area of this triangle from this quadrant area. So we know that this is the 90 degree angle, so this is a right triangle. OBD is a right triangle. So area of a right triangle is equal to half into base into height. The base is given, that is equal to the radius of the circle, and OD's length is given for you if OD is equal to 2 centimeters. So that's also known. We know the base and height, so we can find the area of this triangle. So the second question answer is area of shaded region. Is equal to area of quadrant minus area of triangle. So that is equal to area of quadrant. We know it that it is 77 by 8 centimeters square, that we already find out, minus area of triangle, that is half into base into height. So half into base, we know the base is equal to 3.5. 3.5 you can change in the fraction form, that is 35 by 10, that the lowest form is 7 by 2 into height. Height is equal to 2 centimeter. Now 2 and 2 cancelled, then it will be 77 by 8 centimeter square minus here 7 by 2 centimeter square. Area of the triangle is equal to 7 by 2 centimeter square. When you solve this, we will get the area of the shaded region. Here 77 by 8 minus 7 by 2, you should make the denominator same, or you should take the LCM. So here it will be 77 minus 28 by 8, that is equal to 77 minus 28 is 49 by 8 centimeter square. So area of the shader region is equal to 49 by 8 centimeter square. That is the area of the quadrant minus area of the triangle. Let us see the next question. And the figure OPBQ is a quadrant. A square OABC is inscribed in a quadrant OPBQ. If OA is equal to 20 centimeter, then find the area of the shaded region. Here it's given for you OPBQ is a quadrant, and one square, a square OABC is inscribed in a quadrant. Inscribed means drawing one shape inside another so that it just touches. So here in the figure, a square is inscribed in a quadrant. A figure or a shape square is drawing inside the quadrant. So that square is just touches the quadrant. So we want to find the area of this shaded region. To getting this shaded region, we want to subtract the area of the square from the area of the sector or area of this quadrant. And it's given for you only one measurement, that is OA is equal to 20 centimeter. So when OA is equal to 20 centimeter, that is the side of the square. If we know the side of a square, we are able to find the area of the square. And how do you find the area of the quadrant? To find the area of the quadrant, we want to know the center angle and we want to know the radius. And here it's a quadrant, so the center angle is equal to 90 degree. What is the radius of the quadrant? That is OP or OQ is the radius of the quadrant. How do you get this radius OP? We can, when you observe this figure, you can see that this OP, OQ and this OB, these three are radii of the quadrant or radii of a circle. OP is equal to OB is equal to OQ. So we can find the length of OB because it's a diagonal of a square. The diagonal of the square is equal to the radius of the circle. So we know the side of a square, so we are able to find the diagonal of this square. We can use the Pythagoras property, base square plus altitude square is equal to hypotenuse square. So using that we can find the length of OB. If we get the length of OB, that is equal to the radius of the quadrant. So we can find the area area of the quadrant. So you can subtract area of square from area of quadrant. You will get the area of shaded region. So when you are writing, you have to write radius of the quadrant. Radius of quadrant is equal to OB, or it's also equal to OQ, or it's also equal to OP. So OB is equal to square root of OA square plus AB square. Hypotenuse is equal to square root of base square plus altitude square. Because it's a square, so this angle is a 90 degree right angle. So this is a right triangle. So we can apply the Pythagoras property. So OB is equal to square root of OA square plus AB square. So that is equal to square root of OA is equal to 20. We know that it's a square, so all sides are equal. So 20 square plus 20 square, that is equal to square root of 400 plus 400, that is equal to square root of 800. What's the square root of 800? That we can split it like this: 8 into 100. Square root of 8 is 2 root 2. Square root of 100 is 10. So 2 root 2 into 10, that is equal to 20 root 2. 2 into 10, 20. 20 root 2. The length of this OB is equal to 20 root 2 centimeter. That is equal to the radius of the quadrant. If you get this radius, we are able to find the area of a shaded region. So area of shaded region is equal to area of quadrant minus area of square. That is equal to area of quadrant is equal to 1/4 of the area of a circle. 1/4 pi r square minus area of square is equal to a square. So 1/4 into 22/7 into radius is equal to 20 root 2. So 20 root 2 into 20 root 2 minus a square, that is 20 square. Length of side of the square is equal to 20 centimeter, which is equal to 1/4 into 22/7 into 20 root 2 whole square, that is 20 into 20, 400. Root 2 into root 2 is 2. 400 into 2, 800. So 1/4 into 22/7 into 800 minus 20 square, that is 400. Now here common factor 4 is the 4 2s are 8, so 200 is here. 200 into 22/7 minus 400. So that is equal to 228 centimeter square. So area of the shaded region is equal to 228 centimeter square. We got that area. That is the area of a quadrant minus area of a square. First we find the radius of the quadrant. The radius of the quadrant is equal to the diagonal of a square. A square is inscribed in a quadrant. That means the square will be inside the quadrant. The next question is, And the figure ABC is a quadrant of a circle of radius 14 cm and a semicircle is drawn with the BC as diameter. Find the area of the shaded region. So in the question, it's given for you ABC is a quadrant of a circle. When you observe the figure, you can see ABC. ABC is a quadrant of a circle. This is ABC. It's a quadrant of a circle with radius 14 centimeter. That is the length of AC is equal to 14 or AB equal to 14 centimeter. And there is another figure also there. It's one semicircle is drawn with BC as diameter. So this figure or this design is the combination of a quadrant and a semicircle. So the diameter of the semicircle is equal to BC. We want to find the area of the shaded region. So if you subtract the area of this quadrant, we won't get the area of the shaded region. But we can, if you subtract the area of this segment BC, or you can name it one point, you can give it as P. So BPC, segment BPC. If you subtract the segment BPC from the semicircular portion, you will get the area of this shaded region. So to get the area of the segment BPC, we want to subtract the area of this triangle from this quadrant. From the quadrant ABC, we want to subtract the area of this triangle, right triangle, because it's a quadrant. This angle is 90 degrees. So if you subtract this right triangle from the area of this quadrant, we will get the area of the segment BPC. If we get the area of the segment, we can subtract that area from the area of the semicircle. How do you find the area of semicircle? Do you know the radius? No. We want to first find the length of this BC using Pythagoras property. Find the length of BC, then you will get the diameter of the semicircle. Then you can find the area of the semicircle. From that area, you can subtract the area of the segment BPC. So you will get the area of shaded region. Okay, how do you get this area of this triangle, or what is the length of sides of this triangle? What type of triangle is it? It's a right angled isosceles triangle. It's given for you a quadrant of a circle of radius 14 centimeter. So AC is the radius of this quadrant and AB is also the radius of the quadrant. That is also equal to 14 centimeter. Radius of the quadrant is equal to 14 centimeter. So these two are the sides of this triangle. Both sides are equal now. AB are equal to AC, so it's an isosceles triangle. Isosceles right triangle. Now we can find the area of this right triangle, half into base into height. And the same way we can find the hypotenuse BC using the Pythagoras property, because it's a right triangle. So first of all, we can find the length of BC. In right triangle ABC, BC is equal to square root of AB square plus AC square. That is equal to square root of 14 square plus 14 square. That is equal to square root of 196 plus 196. That is equal to 196 plus 190, or 2 times of 196. 6 2s are 12. 1 is remaining. 9 2s are 18 plus 1, 19. 1 is carry over. 2 plus 1 3, 392, square root of 392. Using the prime factorization method, you can find the square root of 392, or you can use the division method. So using the prime factorization method, the square root of 392 is equal to here 2, 1 2 is 2, remainder 1, 19, 9 2s are 18, remainder 1, 6 2s are 12, again 2, 9 2s are 18, it's 16, 8 2s are 16, again 2, 4 2s are 8, 18, so here 9 times, in 49, 7 7s are 49. So we can make a pairs. In this pair 1 2 we can take it, from this pair we can do 1 7. So 2 into 7 into, there is no pair for this 2, so we can write it as root 2. So the square root of 392 is equal to 14 root 2 centimeter. So the diagonal, the hypotenuse of this triangle BC is equal to 14 root 2. Length of BC is equal to 14 root 2 centimeter. That is the diameter of the semicircle. Now if you get the area length of BC, then we are able to find the area of the segment. Area of quadrant minus area of triangle is the area of segment. So area of segment is equal to area of segment BPC is equal to area of quadrant ABC minus area of triangle ABC. So theta by 360 into pi r square minus area of the corresponding triangle, that is half into base into height, that is equal to area of quadrant, that is 90 degree, 90 by 360, you know that it is 1 by 4 of pi r square. So 1 by 4 into pi value, that is 22 by 7 into radius. Here radius is equal to 14 centimeter. So 14 square minus 1 by 2 into base of the triangle is 14 into height of the triangle also 14. There also 14 square is coming. So that is equal to, here common factors you can cancel, 2 2s are 4, 11 2s are 22. So 11 into 196 by 14 minus 196 by 2. So 11 into 196 by 14 minus 196 by 2. Here there is a common factor 14. So 14 times, so 11 into 14 minus 196 by 2, that is equal to 98. That is equal to 11 into 14, that is 154 minus 98, that is equal to 56 centimeter square. So area of the segment is equal to 56 centimeter square. This shaded portion, area of the segment is equal to 56 centimeter square. Now we can subtract this area from the area of the semicircle. Area of semicircle is equal to half pi r square. Half pi r square. Here Radius of the semicircle. Radius of semicircle is equal to half of the diameter, that is 14 root 2. Diameter of the semicircle is 14 root 2. So half of 14 root 2, that is equal to 7 root 2 centimeter. That is the radius of the semicircle. So area of semicircle is equal to half into 22 by 7 into 7 root 2 whole square. Now that will be equal to, here it is 11 times 11 into 7 root 2 into 7 root 2 by 7. These 7s are cancelled. So 11 into 7, 77. Root 2 into root 2 is equal to 2. So 11 into 7 into root 2 into root 2 is 2. That is equal to 14 into 11, that is 18, 154 centimeter square. That is the area of a semicircle. Area of the semicircle is equal to 154 centimeter. This whole area. Area of this semicircle is equal to 154 centimeter square. Now we can find the area of shaded region. If you subtract the area of the segment, that is 56 centimeter square, you have to subtract from the area of the semicircle, then you will get the area of the shaded region. So area of shaded region is equal to 154 minus 56, that is equal to 14 minus 6 is 8, 14 minus 5 is 9, 98 centimeter square. That will be the area of the shaded region. This is the area of segment. This is the area of segment. That area you should subtract from the area of the semicircle, then you will get the area of shaded region. I hope that you understand this question. You have to practice these questions 2 or 3 times. Note down these questions in your notebook and practice these questions 2 or 3 times. Today's your worksheet is exercise 12.3, question number 10 and question number 16.